Hi everyone, welcome to this video. I'm Shakur and today we are going to solve an interesting problem from the Beer Johnston textbooks together. This problem is about analyzing a bone. First, let's read the question. A strain gauge located at C on the surface of bone AB indicates that the average normal stress in the bone is 1.8 megapascal when the bone is subjected to two 1200 Newton force as shown. Assuming the cross-section of the bone at C to be annular and knowing that its outer diameter is 25 millimeter, determine the inner diameter of the bone's cross-section at C. That is C. Again, we write the basic formula we had. Sigma equal load divided by area. Here we are given the value of stress and also the load. And the only unknown is the area. But there is an important point about the area. Our cross-section is not a solid circle, but rather a hollow circle, like donut. The problem statement gives us the outer diameter of this donut, and we need to use that to find the inner diameter of the hollow bone's cross-section. If we change the formula, we have A equals load divided by stress. On the other hand, we know that the area of donut is P over 4 times the outer diameter squared minus the inner diameter squared. Here we want to know the value of D1. For this, we should move D1 one side. Alright, it's below. D1 square equal D2 square minus 4A divided by P, which A is equal here P divided by sigma. It means D2 square minus 4P divided by P sigma. And now we have D2 load, stress, and P we know that it's 3.14. Now we place number in formula. D1 equals square root 25 millimeters square minus 4 times P equal 1200 newtons divided by 3.14 and the stress equal 3.8 megapascal. 3.8 megapascals. And if we calculate this, the D1 approximately 0.0149 meters. It means D1 equal 40.9 millimeters. Uh, that's it.